Hi, my name is Jason. Today I'm going to be talking about the solution for partition labels. I'm hoping that with this video, it can make the intuition a little bit more clear. So let's say we just have this string, for example, we have A, B, C, E, E, C, D. So what we want from this output is we want to be able to return an array representing the longest length that we can make that in this partition. First of all, we want the most partitions, and we want each partition to have the most characters that reoccur. So for example, in this partition we have A, B, in this partition we have C and E, and in this one we have just D. And the goal of this is to maximize the unique number of partitions, and each partition to maximize the reoccurring characters. So the best way to solve this is, first of all, let me go ahead and write the indexes down. And basically what this solution is going to be, what we can do is we can actually map out the characters. So we know that the last occurrence of A happens at 2, the last occurrence of B happens at 3, and then the last occurrence of C, for example, happens at index 7, and the last occurrence of index E happens at 5, and on and on and on. And the goal of this, the idea of this algorithm, is going to be, given character A, we refer to this index map. So immediately you should think of a dictionary, since it's a constant lookup, and say the last occurrence of A happens at 2. So we'll set this as our new greedy window we want to look at. So then we increment A, this I pointer, let's call this I, let's call this J. And basically what happens here is we say, okay, we now have gotten to B, and B's last index that happens is equal to 3, and that's greater than the current index, so why don't we just move J to 3. And after we do that, we can now increment I again, and we say, okay, the last occurrence of A happens at 2, which is not greater than the current J, so we then increment again, and we reach this condition where I is equal to J. And in this case, what we can do is we can now say, at this partition window, we know 3 minus, and let's have another variable called anchor, which represents the position that we started at. So if we do 3 minus the anchor, which is 0, we result in 3. But we also have to include that last character, so what we want to do is just add 1 to it. So to sum up, I minus anchor plus 1. And then after we get to this step, we want to go ahead and update the anchor. I'm going to give myself more space here. Update the anchor to the current position and start that whole process over again. So just to summarize, if we write this in code, it might make it a little bit more clear. So I'll go ahead and start writing the solution. This is just shorthand for storing the indexes and keys. Rate S. Indexes and keys of the dictionary for each character. Initialize a J anchor, have the answer, and then what we want to do is basically iterate through S again, and we have that first case where J is either, let's say we're currently back in this condition where I'll use a red marker, so as we were discussing before, actually let me just move this around. So if we're at, for example, here, we want the J is currently at 2. But then when we get to B, we want the case where now we know the last index of B occurs at index 3. So we're just going to go ahead and say J is equal to the max of the current J or the last of C when the character C last occurs. So in this case, being B occurs later than A, so we're just going to use that as our pointer. And then if we reach the case where the I index catches up to J, we just simply go, okay, we know now that that is a partition window. We take whatever the current I is, subtracted by the anchor, but we also include that last character as I described here. And then finally, we increment the anchor by I plus 1. What I mean by that is, before the anchor is here, we move it to this current position, and we increment it by 1 because we want the new window to be here. So we go back to, let's say, C. So C is now, we know the last occurrence of C happens at 7. So let's set it to 7. And then if we go to the next index, E, we see that the last index of E happens at 6. Sorry, this should be 6 actually. The last occurrence of E happens at 6, and that is not greater than 7, so we leave it the same. And then when we get to here, where we run into this condition where I is equal to j, we know we have a new partition window, so we append that to the answer. And ultimately at the end, we just return the answer. Okay, just run this code now. Forgot that N. We have the expected answer. If we submit this, we see that this result is accepted. Thanks for watching. I hope this helps you understand the intuition behind this algorithm.